Hey, welcome to Maheshwari chemistry classes. Today our topic is atomic structure. Very important bits. These are very useful for IIT, JEE mains and NET set exams purpose. Listen carefully. First one, above principle fails to explain the configuration of element with atomic number. Okay, so here some atomic numbers given. For that purpose we have to check is it following above rule or not. Okay, so here fails to explain above rule ద్వారా explain చేయలేనిది ఏంటి అన్నాడు. First of all we have to know about what is above rule. Above rule means lower energy orbital first fills, next higher energy orbitals fills. For that purpose 18 electrons purpose 1s2 2s2 2p6 3s2 3p6 it is 18 electrons purpose fulfilled. Later on 21 electrons purpose 1s2 2s2 2p6 3s2 3p6 4s2 3d1 it is also normal configuration, there is no problem. And 27 once we check same ending is 4s2 3d7 will come, but especially 24 purpose final orbital we have to take for that purpose finally it may have 4s1 3d5. Okay, so means 4s is not completely filled even though it entered into the 3d5. Okay, so same type of chromium 24 and copper 29 purpose above principle is not explained perfectly. Okay, so that is why our answer is 3. Okay, next if above rule is not used 19th electron in scandium will have. ఒకవేళ above rule కనుక యూజ్ చేయకపోతే 19th ఎలక్ట్రాన్కి ఎలా ఉంటుంది స్కాండియంలో. ఫస్ట్ వీ హ్యావ్ టు రైట్ ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ 1s2 2s2 2p6 3s2 3p6 4s2 3d1 it is for Z21 nothing but scandium purpose electronic configuration. If not followed above rule he said, right, for that purpose generally if it follows as it is 4s2 3d1 will come, nothing but n value may be 4 and what is that here finally purpose n value 3d is right, n equals to 3 l equals to 2 will come. Okay, so 19th electron purpose it is somewhat different, that is why here our answer is 3. Why? Because here also 4s2 will not come first, 3d only come, that is why automatically n equals to 3 l equals to 2. ఓకే, సింపుల్ బెటా. above rule ఫాలో కాకపోతే అప్పుడు కూడా మనకు 3Dయే ముందు వచ్చేది, అప్పుడు ఏమవుతుంది n వాల్యూ 3 అవుతుంది, l వాల్యూ 2 అవుతుంది. కాబట్టి ఆన్సర్ ఏంటిది ఇక్కడ n3l2. ఓకే, నాట్ n3l0, నాట్ n3l1, నాట్ n4l0. అందరు ఏమనుకుంటారంటే మేబీ 4th ఆన్సర్ కరెక్ట్ ఏమో అనుకుంటారు, ఎందుకంటే ఇది above rule ఫాలో అవుతుంది కాబట్టి 4sలోనే ఎండ్ అవుతుందేమో, 19th ఎలక్ట్రాన్ అయితే 4s1 కదా అని అనుకుంటారు. అలా కాదు, తను ఏమంటున్నాడు క్వశ్చన్ చక్కగా చూడండి, 3Dలో ఎండ్ అవుతుంది above rule ఫాలో కాకపోయినా కూడా. అప్పుడు 3Dలో ఎండ్ అవుతుంది అంటే n వాల్యూ మస్ట్ బి 3, l వాల్యూ d పర్పస్ l వాల్యూ 2, when L0 that is S, when L1 that is P, when L2 that is D. That's why our answer is n equals to 3, l equals to 2. Next question, the electronic configuration in the valency shell of silicon. Okay, so here s orbital filled, p orbital px only 2 electrons are filled. The rule violated is this kind of electrons filling in the orbital. Which rule is not following? Is it above principle or Pauli's rule or Hund's rule or all? First of all we have to know about these 3 rules. Within the 1 minute I will explain, listen carefully. Above principle lower energy orbitals first fill, okay, higher energy orbital next fill. Pauli's principle here Pauli's purpose, okay, so no 2 electrons not equal for all quantum numbers, nothing but n l ms purpose any 2 electrons are not equal. Okay, this is Pauli's exclusion principle. After that Hund's rule. Okay, in this Hund's rule what is that 2 steps we have, first step and second step. First step what is that first we have to share the electrons, first sharing, next pairing. Okay, so this is the first step. Okay, So later on, second step purpose, either completely empty or half filled or full filled high stable orbitals. Okay, so these are the three rules. Okay, once listen now. For example, here 1s2 is there, 1s2 is both are there. 1s orbital lower energy orbital, 2s orbital higher energy orbital. First 1s orbital fulfilled, later on 2s orbital filled. That is Abbo rule. Next, Pauli's rule purpose. One orbit must be filled with only 2 electrons, nothing but in our words, one shell filled with only 2 electrons. These 2 electrons not equal for 4 quantum numbers n, l, m, s. These 4, any 2 may be same, but 4 are not equal. That is nothing but a Pauli's rule. Okay, next Hertz rule purpose. First, for example, I want to take p orbital. Here I have 4 electrons. In that time, don't write like this 2 pairing electrons. This is wrong. So first, 4 electrons purpose. First we have to give one electron. If any extra is there, we have to share. That is first sharing, next pairing. This is the first principle. Later on, here for example, if you take degenerate orbitals, this is the degenerate orbital for p. Okay, like this empty orbital are completely half filled, like 3 orbitals, p0 or p3 or p6, nothing but empty or half filled or full filled high stability. Okay, so which here according to this, just you may imagine it may be S2 and px2 py0 pz0. Which rule is violated means here Hund's rule is violated. Why? Because according to Hund's rule, first sharing then only pairing, but here directly paired, here there is no sharing. That is why third rule, nothing but Hund's rule, is not following. Option 3 is right for this. Okay, next 52. Already I explained these previous questions. That video link description I can provide. Okay, the orbital diagram in which above principle is violated is, okay, given orbital diagrams, above principle violated, we have to check once. What is above rule? Lower energy orbital first fills, higher energy orbital next fills. Okay, so once you check here, it is following above rule. It is also, no, it is following above rule. It is also following lower energy first fill, later higher sharing. Lower energy first fill, next higher jumped. Lower energy first fill, after that higher jumped. But here lower energy orbital not filled perfectly, even though it is jumping to the higher energy orbital, nothing but it is not following above rule. Okay, so it is second option is right. Same kind of electron distribution present in chromium and copper. Okay, already you seen that question number 49 purpose, same explanation. Okay, now question number 53. Which of the following is a violation of Pauli's exclusion principle? Nothing but Pauli's exclusion not following. Okay, so what is the meaning of Pauli's? One orbit must be filled with 2 electrons with opposite spin, and that 2 electrons cannot have same quantum numbers. 4 quantum numbers are not same. Okay, n, l, m, s, principal quantum number, azimuthal quantum number and spin quantum number not same for any 2 electrons. Once you check is the first one, it may be s orbital have pairing and p orbital, px2 is there, py0 pz0, nothing but p orbital purpose is the situation. And here yes, and third option also it is following, but here somewhat different he given. Okay, later on fourth one also following Pauli's principle. Okay, but here once you check second option, in same orbit, okay, that is s orbital filled with 2 electrons with the same spin, but it is not possible, right? So that is why it is not following Pauli's exclusion principle. So our option is 2. Next, the magnetic momentum of ions is determined from which of the following is relation. Simple. Direct formula. Magnetic momentum of ions. How it can determine? With the help of which formula we have to find? First option mu is equal to under root n into n plus 2. Second option mu is equal to g into under root n into n plus 1. Next, third option mu is equal to j into under root z into z plus 1. Fourth option mu is equal to 2 into under root n into n plus 1. So here direct formula magnetic momentum of ions purpose mu equals to n into n plus 2 formula. That is why option number 1 is the right. Okay. Next, the units of magnetic momentum is exar, joules, Bohr magnetana, joule second. Magnetic momentum units Bohr magnetons. Option number 3. Okay. BM units for magnetic momentum. Next, another question. Simple question. Number of unpaired electrons in Mn2 plus. Okay. So Mn2 plus manganese 2 plus ion purpose. What is unpaired electron? Simple. Unpaired electrons number. First we have to write electronic configuration. Okay. Finally it will come 4s2 3d5 for normal manganese purpose, but it is losing 2 electrons, right? For that purpose these electrons will be 0. Okay. Automatically only d5 is have all single electrons, nothing but 5 single electrons, unpaired electrons. That is why our option number 2 is right. Option number 2 means number of unpaired electrons in Mn2 plus is 5. Okay. So this is about atomic structure important bits. Please, if you like this video, please subscribe my channel and please give me your support. Please like this video. Thank you for your patience. Thank you.